welcome back to another video of Math a Day. We're on the 20th video, woohoo! Today we'll be learning the basics of exponential functions with tables and writing their equations. This will be another small series, so let's get into it. Here we have these two tables. We are going to find the rate of change and the initial value of the tables, and I'll explain what that is later. Let's start with our first table. The top represents the input, or x, and the bottom represents the output, or y. With this table, we are going to find the rate of change. To do this, we are going to find the factor of how much y is changing. So let's start. Our first set on this table is 0, 1, then second is 1, 2, the third is 2, 4, the next is 3, 8, then 4, 16, and 5, and lastly 5, 32. We are going to find the factor of which y is changing. This is not how much y is changing though. In this table we can see that y is doubling every time x increases by 1. Like when x increases from 0 to 1, this is 1 or 2 is double the or 2 is double the amount of 1, and then so on. So the rate of change of this table is 2. Now that we have found the rate of change, let's find the initial value. The initial value is similar to the y-intercept like in our slope-intercept video, or our slope-intercept form video. If you were to graph these points, it would cross through the y-axis at 0, 1 because this is where x is equal to 0. So our initial value would be 1. So now I'll write these values down. Rate of change is 2. Initial value is 1. This is the value that we start with. Now that we have found the rate of change in initial value, we can create an equation for this table. The equation is set up as the initial value, so I'll just do I times the rate of change, so I'll just do r to the x power. So this might be kind of hard to see, but we'll just follow this rule. So our rate or our initial value was 1, so we can do 1 times our rate of change, which is 2, to the x power. And this we can set up as a function in function notation. So f of x is equal to 1 times 2 to the x. And this can just be simplified down to f of x is equal to 2 to the x. Now, let's move on to our second table. The first set is 0, 729. The second is 1, 243. Third is 281. Then 327. Next is 449. And finally 53. As you can see, these values are getting smaller. The way they are decreasing is known as exponential decay. I also briefly pointed out an exponentially decaying sequence in my third sigma notation video. I check out that video right now if you haven't already. I will explain what exponential decay is, but it will make more sense once we see our rate of change. So we are going to find the factor of what these numbers are changing, but you probably don't know how 729 and 243 are changing. So we can just divide them to find the rate of change. So we do 243 over 729, which this is equal to 1/3. So our rate of change is 1/3. I'll write that down. Rate of change 1/3. Now that we have our rate of change, I can explain what exponential decay is. Exponential decay is where the rate of change is between 0 and 1. When the rate of change is between 0 and 1, the next value will be a fraction of the last. So it is decaying exponentially. So now we can find our initial value. Our y-intercept would be at 0.29, so our initial value is 729. It's kind of hard to write, 729. So now we can write this in our equation, and I'm going to change this function to g of x since we already used f of x. So I'm just changing the letter. It can be any letter that you want, but I'm just going down the alphabet. So g of x is equal to our initial value, which is 729, times the rate of change to the x power. So it's going to be times 1/3 to the x power. This is how you'd write this table. Oh, that box looked terrible. This is how you'd write this table as an exponential function. That's as far as we will get for today with exponential functions. Tomorrow we will graph these functions and observe their rate of change in initial values on the coordinate plane. I hope you enjoyed this video and learned something new. Thank you for tuning into Math of the Day today. Goodbye.